Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 49th question of the problem solving series and the first question of Q. So we are studying the topic Q and the difficulty level for this question is easy, and this question has been asked in Oracle, Adobe, Amazon, Microsoft and many other companies. So we need to implement stack using queues or queue. So in the previous video, we discussed how to implement a queue using stack. So we saw queue is a first in first out data structure. So in the last 8 videos, we have discussed stack, and stack is a last in first out data structure. So whatever goes in the beginning, uh, will come out at the end, right? So for stack, when we insert in a stack 1, 2 and 3, and the same thing when we insert in the queue 1, 2, 3, but when we pop out from stack it becomes 3 to 1, but when we pop out from queue it comes in the same order 1, 2, 3, right? So this is the difference between stack and queue. Now we discussed how we implement queue using stack in the previous video. Now we will implement stack using queues. Okay, so let's look at the example. We need to implement stack. Okay, so this is so we will be having a class of stack. We will complete these functions, but we won't use stack. We will use queues to make it as stack. Okay, so when this output goes to a stack, okay, so this is the formation of the class stack, and then this is pushed. Okay, so this is the stack, right? We know we form the stack like this as a heap. If this is the stack, so initially 2 went to the stack, okay, then 3 went to the stack, and then we print the top element. What is the top element? 3 is the top element, so 3 comes. Then we push 5 has been pushed, and then we pop out. Okay, so when we pop out, so 5 will be popped out and 5 will be removed here. Okay, and then we check, then we again pop out. Okay, so what is the top element? 3. So 3 will be removed again and 3 will be printed, and now we check whether the stack is empty or not. We can see stack is not empty, there is element 2, so we will return false. Okay, so in this way stack operates. We have already discussed the top 8 questions of stack. You can see in my playlist. Now we need to implement this stack using queue, and for queue it is first in first out, right? As we discussed here, if 1, 2, 3 are pushed to the queue, then 1, 2, 3 only comes out, right? Whatever goes first comes out first. As simple as that. So how will we solve this? So if we take a queue and then we insert into it 1, 2, 4, anything. But if we pop out, the first element comes. But according to stack, the last element should have popped out. How we will make it work like a stack using queue? So if I have a queue and if I push first element to the queue, okay, and then what do I do? For first element, if I pop out, it would behave, the stack and the queue behave same when there is only one element, right? That is one observation. What could be the second observation? That if there are more than one elements in the stack queue, right? If we are inserting more elements, say if we have inserted more elements, then whatever is there in the queue, if we reverse it, how we will reverse it, right? Say if I have 1 inserted to the queue, now I get 2, so 1, 2, 3, 4 are the elements. I have inserted 1 to the queue. Now I have got 2. Okay, so the size of the queue becomes 2. Okay, so what I do, I push this into the queue before pushing this, so 1 is already there, okay. Now since I have one element already in the queue, okay, if I push 2 into the queue, instead of pushing 2 into the queue, what do I do now? It is there, I will actually, I need to make it reverse, right? That is our goal, that if we pop out, then the 2 should come in the beginning, right? So when I pushed 1 and then when I have pushed 2, what I do, I will push the top element to the queue again. What is the top element? 1 is the top element, right? So I'll push this 1 again to the queue. And then I will pop out. So once Q is pushed to the stack, pushed to the queue, what is there in the beginning? 1 only there. I'll pop this element. I'll remove this element. So it becomes 2, 1. Now 3 comes back again. Okay. I push 3 to the queue. Now I have 2, 1, 3 in the queue. Since size of queue is greater than 1, what I do, what is there in the top? 2 is there. I'll push 2 into the queue and I'll pop out 2. What is there in the top? Q 1. I'll push 1 into the queue and then I'll pop out Q. Now once I am done and I see that the top, so now 3 to 1 is the order which I wanted. Okay. So if I do this, the size of the queue actually becomes 2, 3. Our condition was to check for 2, right? So I can actually have 2 queues and do this operation. Otherwise, if I do it like this, so what I can do, 1, 2, 3, this is pushed. So I have the count stored in the beginning only, right? So that won't be a problem. With single queue, we will be solving this problem, okay? How we will solve it? I think you have got the understanding, you have got the intuition what I have done. So let's code it, okay? So in the beginning, I will take a queue, right? Queue in queue. So this is the STL library of queue, and now I'll insert queue dot push x, okay? Then I'll have int size equal to q dot size, int size equal to q dot size. Now I'll have a loop for int I equal to 0 to 2 q dot size, or I can have a condition, same thing. I can have a loop from I to q dot size minus 2 actually. Why minus 2? You'll understand why minus 2. Okay, I need to run, I don't want to run for 3, it's like 1 lesser than the size, right? So if the size is 3, then I want to run it from, so I write the whole loop actually. Then instead of doing the pseudocode, I'll write it like this. For I equal to 0, I should be less than q dot size minus 1 I plus plus. Okay. So if the size is 1, right, in the beginning when we push the element, if the size is 1, then we don't need to do this operation, because for the single element stack and queue behaves same, right? But if the size is 2, so 1 and then 2 comes, then I push 1 to the queue back and then I pop this out. So we are done. I don't need to do it for 2, right? So that is the logic. That's why the size should be 1 less than, if I is 1 less than this, we are done, we are okay, okay? So what we'll do now, so we will push q dot push whatever is there in the front to this q. Okay. Actually, this should be q dot size minus 1. Okay. Q dot push, q dot front, and then what we'll do? We will pop out the. So when we pop out, the front element will be popped out, right? So yeah. So this will work. So actually, we don't need to do this q dot size also. No, we don't have to store the size. We can directly use this because the size will always be same because we are pushing the first element and then we are popping out, right? So that won't be an issue. So once we are done, so this will work. I'll do a dry run and this will be more clear. So we are done. Okay, so this will make it reverse. All the elements which are in the top will come at the behind, right? So for popping out, what we'll do, we'll just normally, if q is empty, then we actually should return -1. By default, return -1, or else int anything, int result equal to q dot front, and then q dot pop, and then return result. Okay. So for printing the top element, we just need to print q dot front. So for stack, for stack we had stack dot top. So for q we have stack dot for q dot front, and for this one we need to print return q dot empty. If it is empty, then it would return true. Otherwise, it would return false. Okay. So this pop, top, and empty is the normal same function, right? We need to see how this push worked. Okay. Let's use this example itself. Okay. So we have formed this is the class, stack class is formed. Then we push. What do we push? We push 2. Okay. This is the list. Say this is the list, stack class. Okay, using q, right? So this is q only. Let's write it as q. Otherwise it would be confusing. This is our list. Right? We are doing a dry run. Now in the beginning we push 2. Okay. So here it goes and q dot push 2, and size is 1 and I equal to 0. I is not less than 1 minus 1 0. So this is false. So q1 will so first element 2 will be pushed, right? Then what is there? Push again. What do we push? We push 3. So now 3 gets pushed to this. Okay, q dot push. Now what is the size? Size is 2. Okay, so now I equal to 0. 0 is less than 2 minus 1. 0 is less than 1. So we come here. Q dot push, q dot front. So what is there in the front? 2 is there in the front, right? So 2 gets pushed over here again. And q dot pop. So what do we pop out? The first element. We pop out this. Right? So now what is the size? Size is 2. But I will be incremented and I will become 2. I will become, I was 0, now I will become 1. 1 is not less than 1, right? So this is done, 3, 2. Now we pop out, we need to print the top element. So what is the top element? 3 is the top element, right? So actually it was, it was given as, the list was 2, 3. Okay, in the stack. So we know the last got printed, right? So we are in the right track. Now again push. Let's do it again. We'll do up to here. Okay. So what happens? Top is done. Now we push 5. Okay. So when 5 is pushed to the stack, okay. So 5 in the queue. When we push here into the queue, so in the so when we push over here 5, so 5 gets pushed over here actually. In the beginning, right? Q, everything gets pushed in the beginning. No, sorry, in the end, everything comes from the beginning. So 5 gets pushed. Now, size of the Q is 3. So 3 minus 1, 2. I is 0 is less than 2. From front, we push. What is in the front? 3. So 3 will be pushed, and from the front it will be removed. 3 got removed. Now 2 would be pushed, 2 will be removed. I and size minus 1 will become equal. So what do we have? 5, 3, 2. And then what is there? We pop out. So when we pop out, so we get 5. So the last element was 5. So in this way, with this logic, a single queue, we could implement a stack, right? So I hope the explanation is clear. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 49th question, implement stack using queue. Okay, so this is example. We have this stack and then we push 2 and then we print top and pop and then whether it is empty or not. So it's the output is in the beginning 1 2 is pushed and then prints the top element. So the last element pushed was 2 and then the top element will be 2 and then false, the normal behavior, the way stack behaves. We need to implement the stack using queue. So we have done the same thing here. Q dot size minus 1, if it is less than I is less than q dot size minus 1, we push the first element back to the queue, so that it becomes the reverse, and then we do the same thing, right? So we already discussed. So we'll directly submit this code. So you can see this has been accepted, and see you soon in the next video where I'll be explaining the 50th question of the problem solving series and the second question of the queue. Jai Jinendra.